All right, let's get right into it. One of the biggest challenges when you're moving apps to the cloud, it's not really the servers, it's the storage. And I'm talking about that old, reliable network file share that your application absolutely depends on. So how in the world do you bring that along to AWS without having to rewrite your entire app?
And that's really the big question we're going to tackle. You've got this app, it works perfectly, but it is completely tethered to a file share. Moving the virtual machines, that's one thing, but that shared storage, that's the tricky part. So let's break down the best way to solve this puzzle in AWS.
So to figure out the solution, we first have to really get to know the hero of our story. Let's just call it the legacy app. It's been doing its job for years, maybe even decades, and now it's time to go to the cloud.
Now, the most important thing to understand about our Hero app is its core need. It wasn't built for a modern object store like S3. Nope. It needs to read and write files in a good old-fashioned folder structure, just like it would on a Linux server. It depends on something called POSIX compliance, which is just a fancy way of saying it needs standard file permissions and locking so that multiple servers can access files at the same time without chaos. This is not a nice-to-have, it's a deal-breaker.
Okay, so you've lifted your app, you've landed in AWS, and you immediately hit a fork in the road. On one side, you see a sign for AWS EFS. On the other, AWS FX. Both of them are promising to solve your file storage problem, but, and this is key, they are built for very different journeys.
Probably the easiest way to think about these two is to give them personalities. Think of EFS, the Elastic File System, as your flexible generalist. It's serverless, it's super simple to spin up, and it speaks NFS, which is the native language for any Linux or POSIX-based system. Then you have FSX. FSX is the specialist. It's all about raw power and specific use cases, like high-performance Windows applications that need SMB or massive high-performance computing jobs that use a file system called Lustre.
So making the right choice here isn't about which one is better. That's the wrong question. It's all about which service is the right fit for your application. And that decision really boils down to looking at 4 key things.
And here they are, in a handy little table. First up, and this is the big one, protocol. If your app is coming from Linux and needs NFS, EFS is literally built for you. If it's a Windows app that needs SMB, well, FSX for Windows is your answer, right there. Next, performance. EFS is awesome for general-purpose stuff, especially workloads that are kind of spiky. FSX is for when you need that consistent, eye-watering speed that you can figure up front. We're talking sub-millisecond latency. Third is availability. EFS makes this super easy. It's highly available across multiple AZs right out of the box. With FSX, you can get the exact same thing, you just have to choose that option when you set it up. And finally, cost. EFS is a true pay-for-what-you-use model. FSX is more like buying a server. You provision the storage and performance you think you'll need, and you pay for that whether you use it all or not.
So listen, if you take one thing away from this, it's this. Before you look at cost, before you look at performance, you have to look at your application. Does it speak NFS or does it speak SMB? Because answering that single question usually points you directly to the right service and makes the whole decision a whole lot simpler. It is absolutely the most important first step.
Now, before we look at the final architecture, I want to tell you a quick story. It's a classic mistake, a real cautionary tale that I see teams make all the time when they're just getting started in the cloud. Seriously, I've heard variations of this story so many times. A team sees Amazon S3, they see how cheap and durable it is, and they think, perfect, we'll just mount that like a network drive. Here's the problem. S3 is an object store, not a file system. It's built for storing and retrieving whole files, or objects. It's not designed for all the tiny, constant read and write operations and the file locking that a real file system does. And the result? The app's performance just falls off a cliff. It's a textbook case of using the wrong tool for the job.
The good news is the fix was actually pretty simple. Once they figured out the real problem, that they needed true file system behavior, the solution was obvious. Since their app was Linux-based, they moved all the data over to EFS. And the second they pointed the application at the new EFS mount target, poof, performance was right back where it needed to be. Just like that.
So what does this winning setup actually look like in practice? Well, you're going to love this. It's actually beautifully simple. Let's put the pieces on the board.
First, you've got your compute layer. This could be anything from your standard EC2 virtual machines to containers running on ECS or even Kubernetes on EKS.
And all of these compute resources, they need to talk to that shared data.
And they do that through a simple little thing called a mount target. This is just an endpoint that lives inside your network, your VPC, and to your application, it looks and acts exactly like the on-prem network drive it's been using for years. And the best part? You don't have to change a single line of code in your app.
And you get to control the performance too. With EFS, you can just use the default bursting mode, which is great for unpredictable traffic. Or, if you need guaranteed speed, you can pay for provision throughput. With FSX, it's even more straightforward. You just tell it exactly how much throughput and how many IOPS you need right when you create it.
Okay, so let's wrap all this up into a simple playbook that you can take with you and use on your own projects. Think of it as your guide to getting this right every single time.
First things first, let's just be crystal clear on when you should even be thinking about this. You need a cloud file system like EFS or FSX when your application was fundamentally designed to work with a shared drive. If it needs things like file locking, folders within folders, and traditional permissions, don't even try to shoehorn it onto an object store. Use the right tool.
So here it is, your final checklist. If your app was originally built for a NAS device, check. If you need a bunch of servers all reading and writing to the same files at the same time, check. If you absolutely need those classic POSIX or Windows SMB permissions, check. If your app is super sensitive to latency and needs real file system behavior, check. If you're nodding yes to these, then a dedicated file storage service is, without a doubt, your answer.
And there you have it. Your migration is done. Your application is humming along happily in the cloud. But I want to leave you with one final thought. You have successfully moved the application, but have you moved your mindset? Using tools like EFS and FSX is a brilliant way to get to the cloud, but the next step on that journey is to ask, could the next version of this app be built differently to use cloud-native services even more effectively? And that, my friends, is the real journey.